Okay, this is problem 22 for help with the honors geometry packet. This problem says that the coordinates of two consecutive vertices of a rhombus are -5, 6, and 4, 9. And the diagonals intersect at 1, 3. Well, the coordinates of the other vertices just play off the fact that 1, 3 is the midpoint of -5, 6, and some other number. So the way that we just look at this, well, if 1, 3 is the midpoint, I just think about it, I could do it algebraically, and I can show you that. But basically all you're going to do is say -5 to 1 goes up 6. So to go up 6 more, I would be at 7. 6 to 3 goes down 3, so I go down 3 more, and this point would be at 7, 0. Okay, algebraically, you could figure it out by saying -5 plus x 2 divided by 2 equals 1. You can also say 6 plus y2 divided by 2 is equal to 3. Basically, you're using the midpoint formula when you do this. You're saying -5 plus something divided by 2 equals 1. Well, to do this, you just multiply both sides by 2, and you could figure this out algebraically. You don't necessarily need to, I think. Just thinking about it, x being 7, multiplied by 2, these cancel. 6 plus y 2 equals 6. Y ends up being 0. So you see the points are just going to be 7, 0 that way. Well, to look at the other one, from 4 to 1, I go down 3 more on that -2. From 9 to 3, I go down 6, so go down 6 more. My other point is at -2, -3. So the other vertices are -2, -3, and 7, 0. And it's because 1, 3 is the midpoint, because diagonals in a rhombus bisect one another. And this actually would have been true had it been a, not just a rhombus, but a parallelogram, any kind of parallelogram. That was 22. Here's 28. Okay, a chord that is distance of 4 from the center with a diameter of 16. Well, information here tells you this is 4, and if the diameter is 16, I know that the radius has got to be half that. Okay, it forms this sector with a minor arc. What's the area of the shaded? So the radius is 8. I know already that this triangle right here is a special kind of triangle. It's actually going to be a 30, 60, 90, because the hypotenuse 8 is twice as big as one of the legs. I already know the other leg is going to be 4√3. Okay, so that's just going to be a fact. That fact also helps me determine the arc angle, or the measure of this arc. Well, if this is 30, 60, 90, then that's going to be 60. This is going to be 60, and the arc will actually measure 120 degrees. Okay, so that is a little preliminary stuff that's really going to help you figure this stuff out. So what I know now is that since that's 4√3, so is this. Okay, that makes the whole chord 8√3, which is going to be useful in a second. But basically, this is the area of a segment. The area of a segment is the area of the sector minus the area of, we'll call it the unshaded triangle, because that's usually what you're going to have. Okay, well, the area of the sector has a measure of 120, so it's the fraction of the circle taken up by the sector. So it's 120 over 360 times pi radius squared. So that gives me 1/3 of 64 pi. So with my calculator, if I could get that out, actually I think I can just pull this one up here. So 1/3 calculator here doesn't seem to want to work, so we'll just pull this back up. So 1/3 of 64 pi, I think it's going to be 64 over 3. There's no, it doesn't break down. So the area of the sector is going to be 64 pi over 3. Okay. The area of the unshaded triangle is a little bit difficult, but not really. It's just going to be 1/2 base times height. Well, the base is this whole thing, which is actually going to be 8√3, or 4√3 plus 4√3. So it's 1/2 8√3 times the height of the triangle, which we already knew was 4. So 1/2 of this is going to be, actually it's going to be 16√3. So basically my answer is just going to be 64 pi over 3 minus 16√3. So that's going to be your final answer for the area of the shaded. Third question on this little tutorial is going to be 32. A lot of stuff in 32. The first question is, what is BD? Well, BD just looking at the problem, is part of this semicircle, okay? And since the semicircle is 180, I know BD has to be 180 minus the 130 that I know, because I know that ED is 130, so BD has to be 50 for that reason. So you got to look for those semicircles. You got to look for inscribed angles, angles outside, angles inside. All that stuff comes into play here. So angle CFH is the next one. Well, CFH is pretty simple. It's a tangent radius relationship. So CFH is going to be 90. EPF. So let's find that. EPF is down here. Well, EPF's a little bit different. Okay, EPF is an angle outside the circle. So assuming that we can just go back and see that other stuff. I know this arc is 50, we'll keep that there. But EPF is this angle outside the circle. Well, I already know that this is 50, this is 80, and this is 130. So I need to figure out what EF is. Well, that's just going to be 360 subtracting all three of the arcs I already know. So 360 minus 130 minus 50 minus 80 lets me say that this is going to be 100. So EPF, therefore, is going to be 1/2 big arc, which is 50 plus 80. So this whole arc is the arc intercepted by the angle EPF in this case. So it's going to be 130. The little arc is 100, so it's going to be 1/2 of 130 minus 100. Half a 30. It's going to be half of 30, so it's going to be 15 degrees. Okay, so far I got A, B, and C. Angle BCF now. If you guys can just, again, you can always go back and rewind and see what I just did for that, and see how I got the things that I got. So, but basically, this is what I got. I found that this is 100, so I'll keep that there. Okay, so BCF is this angle here. That's a central angle. Right away, you look at that, you're like, it's a central angle. C is the center. The arc is 80, so it's got to be 80 degrees. So central angles equal the arc. Angle DEB now is a similar relationship. DEB is just an inscribed angle with its vertex on the circle. So it's half of 50, which is going to give you 25. So that's DEB. DAE now is a little bit trickier simply because that's an angle that's not at the center. So DAE, which is this angle, is going to be the average, basically. It's an angle inside the circle. So we say 2 times the angle equals 130 plus 80, right? So it's going to be 1/2 of basically the average of 130 and 80. So 130 plus 80 is 210. Half of 210 is 105, and that's why DAE should be 105. And then lastly, BFH. BFH is that tangent. Just erase this stuff here. Not the 50, I kind of want to keep that. BFH is that tangent chord relationship, but the angle's on the circle. So vertex is on the circle, therefore it's going to be half the arc. So it's just half the arc that's intercepted, or 40. Okay, I hope this helps for those 3 questions.